In this video, I'd like to provide the solution to some of the questions from exercise level 1 from the A-level Mathematics Further Algebra section 1, the General Binomial Expansion. And at the top of this page, I've written down our general result for binomial expansion that we're going to use in these questions. So in question 1, we are asked to find the binomial expansion, and we're asked to find the first four terms of the binomial expansion of 1 over 1 plus 3x and state the values for x for which this is valid. So we know that this is equal to 1 plus 3x to the power of negative 1, and now that is in a form we can use our binomial theorem. So we have n equals negative 1, and in the place of x we have 3x. So this is 1 plus negative 1 times 3x plus negative 1, and then n minus 1 is negative 2, all divided by 2 factorial times by 3x squared. And then we have negative 1 times negative 2 times n minus 2 is negative 3 over 3 factorial 3x cubed. And then we have our remaining terms we're not asked to calculate. Well, what is this? Well, this is 1. 3 times negative 1 is negative 3. Here we have negative times a negative, so this is positive. And notice that 1 times 2 divided by 2 factorial is just 2 divided by 2, so that is 1. So this is just 9, so 3x all squared, which is 9x squared. In the next term, we have negative 1 times negative 2 times negative 3, so it is negative. But notice that that is equal to 3 factorial, so we have 3 factorial divided by 3 factorial. And then we have 3x all cubed, which is 27x cubed. And then our remaining terms. And we need to state the values for x for which this is valid. Well, this is valid when 3x is between negative 1 and 1. So x is between negative a third and a third. Okay, now let's look at question 2, part 1. And notice here that this number here is not a 1. So we need to be very, very careful about this, because our general binomial expansion was for expanding terms, expressions of the form 1 plus x to the n. And we have 1 plus nx plus n minus 1 x squared over 2 factorial. So there's two things we need to do here. Firstly, we need to deal with the square root and realise we can write this as 4 plus x to the half. Then we need to get this 4, and what can we do with this 4 to get a 1? Well, we can take a factor of 4. We take a factor of 4 inside that bracket. We get 4 lots of 1 plus x over 4, all to the power of a half. But that is equal to 4 to the half, 1 plus x over 4 to the half. Well, 4 to the half is 2. So this is 2 lots of 1 plus x over 4 to the half. And now we can use our binomial expansion with n is equal to a half, and in the place of x we have x over 4. So this is equal to 2 lots of 1 plus a half lots of x over 4 plus n, which is a half, n minus 1, which is minus a half, over 2 factorial lots of x over 4 squared, and then a half, n minus 1, which is minus a half, n minus 2, which is minus 3 over 2, all over 3 factorial lots of x over 4 cubed, and then our remaining terms. So now our job is just to simplify this. So we have 2 lots of 1 plus 1/8 of x, and here it's going to be negative, and then we have a half times 1 over 2 factorial, which is times a half, times 1 over 4 squared, lots of x squared, And then the next term is going to be positive because we've got two negatives being multiplied. And then we have a half times 3 over 2 times 1 over 3 factorial, which is 3 times 2, times a quarter cubed times x cubed. Well, what does this end up being? This is 2 lots of 1 plus an eighth of x minus 1 over 128 x squared. There's a factor of 3 that cancels here. So this is plus 1 over 1024 x cubed. And then if we expand out this 2, we get 2 plus a quarter of x minus 1/64 of x squared plus 1 over 512 x cubed. And when is this valid? Well, this is valid when the expansion of 1 plus x over 4 to the half is valid, and that is valid when x over 4 is between -1 and 1, so when x is between -4 and 4. And finally, I want to look at question 2, part 4. And notice again, we've got this 8 here, and we need to think what we can do to this to make this a 1. So we're going to do the same thing as we did before. We're going to take a factor of 8 inside this bracket. So we get open bracket 8, another open bracket, and then we have 1 minus 3/8 of x, close the bracket, and then close the other bracket, the power of the third. Well, this is equal to 8 to the third multiplied by 1 minus 3/8 of x to the third. And now we have a 1 here, so this is something we can use our binomial theorem to expand. Well, an eighth to the third is just 2, because it's the cube root of 8. So this is 2 lots of 1 minus 3/8 of x to the third. So using binomial expansion with n equals a third, and negative 3/8 of x in the place of x, we have 2 lots of 1 plus n times x, so a third times minus 3/8 of x, plus n, which is a third, times n minus 1, which is minus 2/3, over 2 factorial, multiplied by minus 3/8 of x squared, plus a third, multiplied by negative 2/3, multiplied by negative 5/3, all over 3 factorial, multiplied by negative 3/8 of x cubed, plus our remaining terms. And now we just need to simplify this expression. So this is 2 lots of 1 plus, here the 3's cancel, but there's a negative, so it's subtract 1/8 of x, plus, well, this is going to be negative because we have a negative times by a negative squared. So we have a third times 2/3 times 1 over 2 factorial, so a half, times by 3/8 squared, which is 3 squared, over 8 squared, lots of x squared. And then here we have 5 negatives being multiplied, so this is also negative. It's a third times 2/3 times 5/3 times 1 over 3 factorial, which is 1 over 3 times 2, times 3 cubed over 8 cubed, x to the power 3, plus the remaining terms. Okay, and now we want to cancel some factors. So the first two, we get 2 lots of 1 minus an eighth of x. And here we have two factors of 3 that cancel and a factor of 2 that cancels. So this is subtract 1/64 of x squared. And in this next term, again cancelling factors, these 3 3's cancel with the 3 cubed. The 2 cancels here. So this is subtract 5/3 times 8 cubed, which is 1,536, lots of x cubed, plus the remaining terms. And then if we expand out that bracket, we get 2, subtract 1/4 of x, subtract 1/32 x squared, subtract 5/768 x cubed, plus our remaining terms. And we need to state which values this is valid for, or this is valid when the binomial expansion of 1 minus 3/8 of x to the third is valid. So it is valid when 3/8 of x, negative 3/8 of x is between -1 and +1, while multiplying by 8 and dividing by 3 and dealing with the negative, we get x is greater than -8/3, but less than +8/3.